Well, I'm simply saying here, it's not a priori obvious that there is a maximal limit to the extent to which you can excite a given region of space. It's perhaps plausible that if you take a given region of space, you could excite it to arbitrarily high levels, and that would correspond not to one black hole, but the more you excite it, to the bigger black hole you would get. Okay? In this picture, so in the picture of holography, if one takes a black hole, so now I'll make this a black hole of size r. In this picture of holography, somehow when you have a black hole of size r, this region is maximally busy. There is no way you could do anything else inside this region. It's perhaps plausible, though, that a black hole typically does not look like that. Perhaps a black hole of size r typically has only some excitations, and in fact is sort of quiet near the outside. Why not? Or to say it differently, if you give me this configuration, which you believe is maximally excited here, well, what physical mechanism would prevent me from putting in one more long wavelength photon that just fits inside the black hole and adding a small amount of additional energy to the black hole? Now, there may be such a mechanism. I certainly haven't proven that there is not, because there are many parts of this we don't understand. But I simply wish to make it clear that holography is a research direction and an idea for black hole thermodynamics, and not in any way, as far as I can tell, a conclusion of what's known about black holes to date. Oh, yes. But that by itself is not holography. That's merely the entropy of a black hole. A over 4 is a calculation we can do. Black holes have an entropy A over 4.
Sorry.
Yes?
I don't follow your argument either.
Okay.
So if I take the viewpoint that instead of seeing a region of space being maximally excited,
right,
I see in the development leading up to the black hole. So it reaches a point where I've got these highly excited modes that eventually become gravitationally unstable, and I form a black hole. That just tells me that I can't know anything more about those higher states of excitation. Right?
I'm not sure I entirely followed that, but it sounded good.
But so in other words, I mean, what you're suggesting is that you can add more energy, or there are higher energy states available inside the black hole.
Right.
But I mean, won't this have an effect on the actual size of the black hole?
It has an effect on the size of the black hole. The question is that the same as what's being discussed here?
But I mean, they are tied with each other in a sense. Because I mean, as soon as the size gets bigger, then your area has to get bigger. So you in a sense, catering for that extra entropy that you add into the black hole.
The question is, let's see, how shall I put this? So the question is, if I excite some bit of states here, and they make a larger black hole around it, okay, do I get to count the small area that contains the stuff making the black hole, or am I forced to count the larger area of the black hole itself? Okay. And this is a question which I think is in principle unclear. If the black hole is in fact formed by things in a small region, then perhaps in principle one could talk about things in that smaller region. And in fact, if I was inside the black hole, it would be natural to do so. Because as we saw, if you fall into a black hole, you naturally enter a region where, in fact, the space itself shrinks. Right? You naturally enter a region where the space becomes very small. So indeed, even in a large black hole, if you fall into the black hole, you naturally enter a region where everything that made the black hole is contained in a much smaller size. Okay. Now, as perhaps is clear, this is not so much an argument as a discussion about what the rules are, how one should count things, etc. Okay? And good. So I just want to make it clear that that is sort of the state of the art, that people are discussing these things and wondering what the right rules are for studying effects involving black hole and quantum mechanics. if I had a few, you feel free to ask me later about other pros and cons of holography. There is a large list of things that one can say to argue for holography. However, there is an equally long list one can give to argue against those things. So again, it's very much an area of open debate. I should say the summary is, as far as I am concerned, I find that there is no completely conclusive argument for holography. But on the other hand, neither is there a clean-cut example of a situation where it clearly fails. This makes it a very interesting area for further research. All right, great.
Let's end there. And thank Don for an excellent series of regular lectures, and then thank you for putting on this extra one. And we can probably field further questions on trips.
Absolutely.